Good evening, dear students. Today we will be continuing on whatever we have discussed in the last class related to the equation of a straight line. And today what we are going to discuss is that equation of a straight line in normal form. And if you recall, dear students, that what about the different forms of straight lines we have discussed so far. First one was that slope intercept form. Then we discuss about that point slope form. Then we discuss about the 2 points form. Then we discuss about that intercept form. Then we discussed about the symmetric form or distance form or parametric form. So these are the five forms we have discussed so far. Now today what we are going to discuss is that the normal form, and that I'm going to discuss with you. But before I discuss, so I would like to just get a clarification from few of you, is that you are able to hear my voice very clearly and able to view the screen properly, dear students.
Yes,
Okay, great. Now what is normal form? What is normal? Normal generally tends for it is represent for a perpendicular. Okay, and now let's see that what is a normal form representation. And dear students, whatever the equation of the straight line we have discussed so far, always we have observed one thing that was always true for in each of every form of equation of the straight line, is that two information has been given to you. Correct? For example, if it is a slope intercept form, then it is the slope which is given to you and the y-intercept given to you. If it is a point slope form, a point is given to you through which the straight line is passing and the slope of that straight line given to you. When it is a 2 points form, that means the coordinates of the 2 points given to you. When it is in intercept form, then both x-intercept and y-intercept is given to you. So the point is that here also in the normal form, that two information is given to you. What are the two informations that we are going to discuss now? So to let me first draw the coordinate axis, and our preferable coordinate axis is the Cartesian coordinate axis, and I draw it here. So x dash, and y dash, as you see here, and this is the origin. Okay, this is the origin. Now what happened is that normal form, the equation is something like this. Suppose I have a straight line something like this. Now there are two information given for this straight line. Okay, that the straight line is such that the length of the perpendicular from the origin to the straight line is given, that is p. That means from the origin, if I draw it in a different color, that from the origin, if I draw a perpendicular to that straight line, okay, length of this perpendicular is actually denoted by p. That is the first information given to you. And the second information what is given to you is that this perpendicular makes with the positive direction of x-axis an angle is alpha. That means this angle is alpha. This is the normal which makes. Okay. So as it is a perpendicular, that is why it is known as a normal form, dear students. That is why it is called a normal form. And alpha is the angle made by this normal, okay, with the positive direction of the x-axis. So let me tell you once more. Suppose with respect to this coordinate axis, we have a straight line L, okay, such that a perpendicular drawn from the origin to that straight line, is having length p. That means if we consider that if n be the foot of the perpendicular drawn from the origin to that straight line, then ON is equal to P. So obviously, one thing though we are pretty sure that ON is perpendicular to L. That L is the straight line. That is the number one point. And second one is that ON, the length of ON is equal to P, and angle alpha is you know that XON is equal to alpha. That means that angle XON, that is equal to alpha. That means that normal ON makes an angle alpha with the positive direction of x-axis. Okay. Then what we are going to find, what is the equation, dear students? The equation of this form is that, equation of this, so if I write this thing, is that, the equation of a straight line such that the length of the perpendicular from the origin to the straight line is P, and the angle this perpendicular makes with the positive direction of x-axis is alpha, is x cos alpha plus y sin alpha is equal to P. This is the equation of the straight line. Okay. This is the equation of the straight line. I hope all of you are able to view it. Okay. That x cos alpha plus y sin alpha equal to P is the equation of the straight line. So x cos alpha plus y sin alpha is equal to P. Now, if you recall the, in all of our previous sessions, and all these sessions lectures are available in both in YouTube and also available in the online test platform. This equation can also be represented in the, standard form. What is the general equation of a straight line in standard form? That is actually ax plus by plus c is equal to 0. If I write in a different color, that equation is that ax plus by plus c is equal to 0. So this equation x cos alpha plus y sin alpha equal to P, that also we can write is that cos alpha. So we can write here, this implies cos alpha into x plus sin alpha into y minus P is equal to 0. That means as if that A is equal to cos alpha. If you make an analogy with this one, you will get A is equal to cos alpha, B is equal to sin alpha, and C is equal to minus P. So we get x cos alpha plus y sin alpha equal to P. So this is the normal form. Now what we are going to do is that the way we have done for the other forms also, we are going to solve a couple of problems, and we'll see that how to solve this one. You please open your notebook as well, and we'll solve together. Okay. The first question will be available to you in another few seconds, and here it is. So the question is that find the equation of the line which is at a distance 3 from the origin, and the perpendicular from the origin to the line makes an angle 30 degree with the positive direction of the x-axis. So if we draw the relevant geometrical representation of this particular problem statement, let me first draw the coordinate axis x, so x dash, y o, y dash, that is origin, and our straight line is something like this. Sorry, our straight line is something like this. What this is the equation of the straight line we need to find. Okay, And what is the the information given, that which is at a distance 3 from the origin. So generally, the distance from a point to a straight line is actually perpendicular distance. So that means from origin, if we draw a perpendicular to the straight line, and if n be the foot of the perpendicular, then what is given to us is ON is equal to 3. Okay. The orientation of the straight line will be little different. Just a minute. So orientation of the straight line will be little different based on the question. So the straight line should be something like this. Okay. So that if we draw a perpendicular from origin to that straight line, and if we consider n be the foot of the perpendicular, then this angle according to the question is 30 degree. And ON is equal to, which is known as P, that is given as 3. So what is in context to our question, what we get is that we get P is equal to 3 and alpha is equal to 30 degree. So the required equation is, is x into cos alpha, that is x cos 30 degree, plus y into sin alpha, y sin 30 degree, that is equal to P is equal to 3. Now we know the value of cos 30, that is equal to root 3 by 2. So x into root 3 by 2 plus y into sin 30, we know that is equal to 1 by 2, that is equal to 3. So from here, what we get, the equation as root 3 into x plus y is equal to 6. This is the equation of the required straight line. Never hesitate to let me know if you have any smallest doubt. Then the next question we are going to solve, dear students. Okay, and next question I'm going to make it available to you in another few seconds. So in this question, what has been asked is that find the equation of the straight line upon which the length of the perpendicular from the origin is 5 and the slope of the perpendicular is 3 by 4. Okay. I will appreciate if you can start doing it to it. Okay. So let me first, you also do along with me. So let me first draw the coordinate axis x. It is x dash, that is origin, that is y o y dash. The equation is such that the length of the perpendicular from the origin is 5. So if we draw the straight line, so this is the straight line, suppose that is the L be the equation of the straight line which we need to find. Okay, and what are the conditions given? That is the two informations given. The first one is that length of the perpendicular from the origin is 5. That means if I draw a perpendicular from the origin to that straight line L, and what I'm drawing it in the green color. So suppose ON be the foot of the perpendicular. So according to the given question, ON is equal to given as 5. And what is given? And the slope of the perpendicular, that means the slope of the line ON, that is given as 3 by 4. Means if we assume this angle is equal to alpha, then what is given? You know, tan alpha is given is equal to 3 by 4. Now, what is our required equation? The required equation is that x cos alpha plus y sin alpha equal to p. And p is nothing but ON, that is the given. So now from tan alpha equal to 3 by 4, we need to find the value of cos alpha and sin alpha. And let's see how we can do it. So tan alpha is equal to 3 by 4. So from here what we can write is that sin alpha divided by cos alpha is equal to 3 by 4. This implies sin alpha by 3 is equal to cos alpha by 4, that is equal to square root of sin square alpha plus cos square alpha divided by square root of 3 square plus 4 square. Okay, so from here what we get? From here we get sin alpha by 3 is equal to cos alpha by 4 is equal to square root of sin square alpha plus cos square alpha, that is equal to 1, and square root of 3 square plus 4 square is equal to square root of 5 square, that is equal to 5. So from here what is the value of sin alpha we get? The value of sin alpha you get is equal to 3 by 5, and value of cos alpha we get is that 4 by 5. Correct? Now as we get this thing, so what is the required equation? So the required equation of the straight line is that the required equation the straight line is x into cos alpha. X into cos alpha is what? So let me write the form first, plus y into sin alpha, that is equal to p. That implies what? Cos alpha is equal to 4 by 5. So 4x by 5 plus sin alpha equal to 3 by 5. So 3y by 5, and p is equal to what? That is given as ON, that is equal to 5. So this implies 4x plus 3y minus 25 is equal to 0. This is the equation of the straight line, required straight line. I hope it is clear, dear students. Any smallest doubt, never hesitate to let me know. So now this is all about the different forms of the straight line. Now we can discuss about the general form of a straight line, and we will see that from the general form of a straight line how we can find different attributes of a straight line. Different attributes like what? Slope is an attribute, intercept on the x-axis, intercept on the y-axis, and all these things we are going to find it out, and what is the length of the perpendicular from the origin, and all these things. Okay, so let's discuss one by one, and that is the general equation of a straight line, that general form. So what is the general form? So that will be the topic of our discussion. So let me start with a new page. So the general form of a straight line is, general equation of a straight line is of the form ax plus by plus c is equal to 0. Okay, and we have discussed this thing, this particular form several times, during our previous few sessions discussion. So let me read out once more. The general equation of a straight line is ax plus by plus c is equal to 0, where a, b, c belongs to R, that is the set of real numbers, and both a and b cannot be 0 simultaneously because of obvious reason. If both a and b is equal to 0 at the same time, then what will end up with c is equal to 0, and c is equal to 0, so obvious possible. But then what about the equation of the straight line? Then we cannot realize the equation of the straight lines. Hence a and b cannot be 0 at the same time. Now let us assume that A will be the straight line whose equation is of the general form ax plus by plus c is equal to 0. Then we can calculate the following attributes of the straight lines. So let me first show you this thing. The first attribute I would like to discuss some details on this thing. The slope is minus a by b. How the slope is minus a by b, I want to discuss with you. So how the slope is become minus a by b? So let me do one thing then. Let me only give that the slope is minus a by b. So how come? Let me show it to you. So what is the equation? Equation is that ax plus by plus c is equal to 0. Now from this equation, what you can write is that by is equal to minus ax minus c. So from here you can write is that y is equal to minus a by b into x minus c by b. So minus a by b into x. So this minus a by b, if you make an analysis, analogy, not analysis, analogy with y is equal to mx plus c, correct? That is the slope intercept form, dear students. What is that m? M is nothing but the slope, and which we find it here is that minus a by b. Hence we say the slope is minus a by b. That means if we get an equation of a straight line something like this, ax plus by plus c equal to 0, then its slope is minus a by b. Got it? Now the next point is that what is the intercept on the x-axis and y-axis? Okay, so that we are going to find it out now. So from that equation ax plus by plus c is equal to 0, let me use a different color here. So what we can write is that ax plus by plus c is equal to 0. From this equation we can write ax plus by is equal to minus c. So from here what we can write, x by minus c by a, correct, plus y by minus c by b is equal to 1. Now if you make an analogy with this form, of the form is that x by a plus y by b is equal to 1, isn't it? That x-intercept is minus c by a, correct? And that is why we mentioned that x-intercept is minus c by a, and y-intercept is minus c by b, as we get it from there, the other part. And obviously, when we say that x-intercept is minus c by a, obviously it cannot be equal to 0. If x-intercept we are talking about, it should have a value, na? So it cannot be 0. Hence, we are able to write it as at minus b by a. sorry, minus c by a. And similarly, the y-intercept cannot be equal to 0. Hence, b cannot be 0. As b cannot be 0, we can write is that intercept on the y-axis is minus c by b. Correct? So this is about the intercept on the x-axis and y-axis respectively. Okay. Now, the next point what we can discuss is that, let P be the perpendicular, P be the length of the perpendicular from the origin to the straight line L, and alpha be the angle made by the perpendicular straight line with the positive direction of x-axis. Then what we can get? Okay. Let me show you this thing. So what is meant by that? That if P be the length of the perpendicular from the origin to the straight line, and L of the straight line L, and alpha be the angle made by the uh, perpendicular made by this perpendicular with the positive direction of x-axis. Okay. Then what does it mean by that? If we draw it in a different color, so if these are the coordinate axes, x dash, y dash with O as the origin, and suppose this is the straight line. Now this straight line, P be the length of the perpendicular O to the straight line. That means this is P. And what is alpha? Alpha is the angle made by this perpendicular with the positive direction of x-axis. So from ax plus by plus c is equal to 0, how we are going to derive it? So we can divide both sides, by square root of a square plus b square. So a by square root of a square plus b square into x plus b by square root of a square plus b square into y plus c by square root of a square plus b square is equal to 0. Correct? Now, what we can say from here is that, that P, if we represent this, in the form of x cos alpha plus y sin alpha equal to P. So let me first write it down here, that a by square root of a square plus b square into x plus b by square root of a square plus b square into y, that is equal to minus c by square root of a square plus b square. Now, this equation what I wrote now, we can make an analogy with the normal form. What is the normal form? If you recall the normal form is that x cos alpha plus y sin alpha is equal to P. So now this equation, that a by square root of a square plus b square into x plus b by square root of a square plus b square into y is equal to minus c by square root of a square plus b square. Then what we can say, cos alpha is equal to a by square root of a square plus b square, and sin alpha is equal to b by square root of p square, and p is equal to mod c by square root of a square plus b square. Now if c is negative, then we get the value of cos alpha and sin alpha like this, and if c is positive, we get the value of cos alpha and sin alpha like this. Okay, so this is another attribute with respect to the normal form of the general form of the equation of the straight line. Now the last 2 points I would like to discuss with you. The first one is that the length of perpendicular from any arbitrary point x1 y1 to the straight line L. What does it mean? So suppose we have a straight line. Okay, so suppose this is a straight line and this is a point. And what is the equation of the straight line? Equation of the straight line is that ax plus by plus c is equal to 0. And suppose this p is a point with coordinate x1 comma y1, and from that point p we are drawing a perpendicular to the straight line, and suppose n be the foot of the perpendicular. Then what is the value of pn? The value of pn is equal to, so I can write it here, the value of pn, that is the foot, that is the the length of the perpendicular drawn from that point to the straight line, is equal to mod value of ax plus by plus c is there, na? So instead of x you write x1, so that is ax1, plus instead of y you write y1, that is by1, plus c divided by square root of a square plus b square. That mod value is known as the length of the perpendicular from any arbitrary point x1 comma y1 to the straight line L. Okay, so this is as the foot of the that is called the length of the perpendicular. Let me show you this particular statement here. Okay, now the last point for today, what I'm going to discuss is something like this. Two arbitrary points x1, y1 and x2, y2 will lie on the same side of the straight line if there is a condition is satisfied, and they will be in the different side of the straight line if another condition is satisfied. So what are those conditions that we are going to discuss? So as you see here, dear students, that two arbitrary points, that is x1, y1 and x2, y2, lie on the same side of the straight line L if value of both the expression ax1 plus by1 plus c and ax2 plus by2 plus c are of the same sign. What is the geometrical representation? Suppose this is a straight line, which is the straight line L as given, whose equation is ax plus by plus c is equal to 0, and we get 2 points. Suppose one point is x1 comma y1, okay, and another point is x2 comma y2. So now with respect to this straight line L, the point x1, y1 and x2, y2 could be at the same side of the straight line, or they are in the different side of the straight line. That means it may possible that x1, y1 is here, but instead of x2, y2, it is in the other side of the straight line x2, y2, other side with respect to the side where that x1, y1 is present. So here is the condition. The first condition, as you just see, they will be in the same side of the straight line L if both the expression, that is ax1 plus by1 plus c and ax2 plus by2 plus c, are of the same sign. Means either they are both are positive or both are negative. In fact, we can write this thing as, this implies, what, ax1 plus by1 plus c into ax2 plus by2 plus c, that should be greater than 0. Because if both are positive, their product is positive. If both are negative, then their also product is positive. And they will be in the opposite side of the straight line L if the expression ax1 plus by1 plus c and ax2 plus by2 plus c are of opposite sign. That implies what? That implies ax1 plus by1 plus c into ax2 plus by2 plus c is actually less than 0. Very important. Sometimes questions come, with application of this kind of straight line. So here I would like to conclude the class for today, because this is a logical conclusion. And in the next class, what we'll discuss about, the result with respect to two or more straight lines. Okay, we'll learn that, okay, under what condition two straight lines will be parallel, under what condition two straight lines will be perpendicular to each other, okay, under what condition the two straight lines will be identical to each other, if the angle between the two straight line is theta, how we can find the value of theta, okay, how we can find the coordinate of the point of intersection of these two straight lines, and other relevant point, they are bisected, and relevant points. So with this note, I would like to conclude the class today, dear students, and we will have our next class tomorrow, same time. Thank you very much.
Thank you.
Thank you.